Okay, let's take a look at some buses, some address buses, some data buses, and what that concept means in computing. So again, if we went back to our example of the new M1, right? We've got our 8-core GPU and CPU here, and it also says there's this unified memory architecture. So what they're doing is saying in this system, let's say that we're going to have 8 gigs in this system. The 8 gigs is right here on chip. It's right there under the same hood. And being that close means that it's going to save some time because you have this going on. You have buses. So an address bus is an internal communications pathway that specifies the source and target address for the memory. That's all that bus does. And so you need to understand we're not really comparing it to a school bus or some kind of thing. This is coming from the electrical terms. And this is a pathway, an address pathway. And that pathway is just being used to specify where it's going to put stuff. And so modern processors all use a 64-bit address bus. Because you're having a 64-bit address bus, that means this is, we talk about bits, it affects different things different ways. So here, the way this affects it is saying we can have 16 terabytes of combinations, right? When you're talking about an address bus, what you're talking about is I got a whole bunch of RAM here, but in order to use it, I've got to address each individual little storage spot. It's like basically going in and have a bunch of squares, and you got to, oh, that's 1A. And this, just like in dealing with Excel, that's 1B. You have to address where can I put this memory. If you don't have any of that addressed, you can't put it anywhere, right? It wouldn't know where to go. And so when it's a 64-bit address bus, you're basically saying I can address much more space. I can address up to 16 terabytes, right? So that's your RAM, right? I'm running 16 gigabytes. Right, that's nowhere near terabytes, but my address bus could actually address so much more without a problem. Now, data bus allows a computer components such as the CPU, display adapter, main memory, a graphics card, USB, anything that's carrying data, right? That's what a data bus is used for. So there's tons of data buses. Tons and tons of data buses because you're moving things from the CPU to RAM, RAM CPU, graphics CPU, you're moving stuff all around all the time. So the number of bits in a data bus indicates how many bits of data can be transferred from memory of the CPU in one tick. That's not the same. This is, oh man, I can address a ton of space using 64-bit address bus. This is, oh, I've got 64-bit address bus. That means I can, what they call chunk, I can process 64 bits at a time. So in one little tick, whatever that tick is, I can do 64 bits. As a comparison, back in the old days, we started with 8-bit, really, with computers as home computers. They were 8 bits. I can process 8 bits at a time. This can process 64 bits at a time. That's a lot more, meaning that alone is going to make it faster. Now, on top of that, just to point it out, because I brought out 8-bit, a lot of times that's used, 8-bit, 16-bit. That's dealing with color. And that's really where everything gets confused. And so we were running 8-bit processors. That's 8-bit computing. That's 8-bit. You see a certain number of value of colors on the screen. Right. And then that started to diversify. And so you ended up with a 16-bit processor and a 32-bit color palette. And again, when you're talking about a color palette, that's how many colors can I see, just like how many addresses can I use. When you're talking about a data path, I have a 128-bit data path from my processor to my graphics card. That's how much data can I chunk at a time and put on that line at a time. So different stuff, and I just want to clarify all that so that you have a good, solid understanding, because when you see these bits attached to different things, it can be confusing. So realize, are we talking about storage space? That's how much storage I can have, and that usually has to do with the address bus. And then how fast I can go, how many bits can I actually compute in a single time, push down a pathway at a single time. That's different. And of course, you've got how do you control that bus through IRQ requests. And I think we're going to stop there. We'll look at some of the others in just a minute, but that is a good stopping point on that topic.